Since the Dragon cargo vehicle was berthed to the station a week ago, this past Sunday, the Expedition 39 crew members have been unloading its contents, setting up experiments, and also stowing away supplies. This week, more cargo is going to be unloaded, but the human crew on orbit is actually not involved. Canadarm2 will be used to remove payloads from Dragon's trunk and install them on the station, and the arm will be commanded by flight controllers actually here on the ground. Joining us this morning to discuss operations scheduled to begin tomorrow, actually, is Troy McCracken. Troy, thanks for joining us here. You're the lead robotics officer for this operation, is that right?
That's affirmative. Thanks for having me. Yeah, I'll be leading all the cargo operations, as we call it, for the SpaceX trunk.
Yeah, one of the questions is how often do we actually use the robotic arm for ground, like what you're planning on doing, the ground commanded operation?
The majority of our robotic operations now are actually ground commanded. Over the years, we've grown our capability. We started out with simple maneuvers and walk-offs, and now we're doing the majority of the cargo operations, the FRAM transfers. We've also done an RPCM R&R out in the truss.
Why is ground commanded preferable? There are obviously certain cases, but why is it preferable to having you guys do it on the ground rather than the crew on orbit?
The crew's time is very valuable on orbit, and so the more we can do from the ground to support station, the more we're helping the entire program. The SPDM operations are very complex. There's lots of different things you have to know and do, and the training that we'd have to provide the crew is also quite high. So early on, they kind of decided that they would back the crew training down on the SPDM and have them focus on the critical crew ops with the big arm, and that's really the track and capture events where we're capturing and releasing the visiting vehicles, where you have to have the crew member there, focus their training there, and then they also support the EVAs whenever there's one of the external crew members are outside and they're flying. Well, they can step into the arm and we can fly them around on the arm.
Right.
So when we're doing that, we definitely want to have a crew member on the sticks inside flying the arm.
Right. So focusing on Dragon itself, obviously, and your operation that's scheduled this week, describe to us where these payloads are. They're on the external part, obviously. Describe where they are now and where they're headed.
Okay, we have two payloads coming up in the trunk. We have HDEV, which is the high definition Earth viewing payload that has some cameras. So we'll be reaching into the trunk with the SPDM and the SSRMS, pulling it out of the trunk, and then we'll be flying it over to the Columbus module, where we'll be installing it on the Nader exposed facility, so that those cameras can look down on Earth and do some viewing there. The next payload is OPALS. You also saw that in the trunk. We'll be pulling it out of the trunk, and this one's much more complicated. It has to go out on one of the ELCs on the end of the truss. So to provide power to it, we'll stow it on the SPDM itself. There's a EOTP platform on the SPDM where you can attach these FRAMs, and then we can provide power to them and keep them warm. So once we install it on the SPDM, we actually have to stow the SPDM on a lab, PDGF, stow it there, and then we walk off with the big arm over to the MT. Then we'll reach back and grab the SPDM and pull it off the lab. After we do that, then we'll translate the MT out to worksite 7, so farther outboard. And once we get out there, we'll install the OPALS on the final destination on ELC on the Nader side of the payload.
Are there, obviously the transit paths, are there any problems with some of these transit paths in terms of training or where you're headed with these payloads?
The real issue now is clearance. With all the modules that we put on station, whenever we come up on the port side when we're walking off, basically we have to come up between the GEM module and the truss. The GEM module has an exposed facility out there where they've attached payloads with appendages. So whenever we're coming up that corridor, we have to watch our clearances. When we're just maneuvering the SSRMS, that's not really a big issue because it's pretty small, but when you start putting modules or the SPDM with its arms hanging off, right, you really have to coordinate where you go through. So when we're going through this corridor, we'll actually slow down. We'll have to change our payload file and go to slower rates as we go through that tightest clearance. And then once we get through it, we'll go back to our higher rates where we can move the arm at a faster speed.
I know that I think it was late last week and maybe early this week, you guys have done obviously some preparatory work. The station has unique capabilities. Can you talk about the changes that you've made in terms of like its operating base for the preparations for your activities this week?
Right. In preparation, first we had to translate the MT out to worksite 6. So the MT is normally where we store the SPDM, so it's kind of up on the truss out of the way. We have to be on node 2 with the big arm to do the capture and install the vehicle. So after that was completed, we needed to translate the MT over to worksite 6, and then we went and unstowed the SPDM from that MBS. After we did that, since this is the first flight of Dragon where we're doing these FRAM payloads, we took the SPDM and put it in a hover position over the top of the trunk so that we could use the SPDM cameras to do a survey of the trunk, make sure that everything in there survived launch and was where we were expecting it to be, and there was no issues.
We actually just saw a live view of the robotic arms, the SPDM and Columbus, as we talked about earlier, and as we're talking about now, we're talking with Troy McCracken, who is a lead robotics officer. The Robo console is right here in Mission Control. In fact, Troy's been on console for quite a bit in preparation for these activities. Troy, can you talk a little bit about the manual flying versus program maneuvers? Are you guys going to be mostly doing manual, or are there program commands? How's that work?
All the ground control commanding is pre-programmed. We use OCAS, so you give it a destination and the arm automatically flies to that point. Unlike the crew, that they actually have the hand controllers where they can just put in manual inputs and the arm responds to that. Everything we do on the ground is a destination and a automatic maneuver. With that said, we have developed a new tool in the recent past where when we get in close and we have to do these alignments, when we bring a payload down, we're never perfectly aligned. So we'll have to do these minor corrections, and we've developed a new tool where we basically just dial in. We want to go a centimeter to the left or do a degree in pitch. We'll dial that in, and you hit do it, and the tool basically sends the couple commands you need to do to set up the system, and then there's one final command we send that says proceed, which makes the maneuver. And so it's simplified those little minor corrections that we have to do, and that's all based in real time when we get in the actual downlink video and comparing to what we're seeing to make sure that everything's lined up before we actually do the mate of the payload.
Well, I know you're well trained in doing this, but there has to be sort of a cool factor to being able to operate this robotic arm from the ground for that station 260 miles up.
It is always definitely, you step back, and when you see the arm moving, in the video, you'll step back and see that in the middle of your operations, and you always realize it's a great job here to be able to do this, and it's amazing that we've gotten this far.
Well, I know we really appreciate you stopping by the console over here in the front corner of the room, Troy, and good luck with all the operations this week. Thanks again.
Thank you.